Hi everybody, my name is Antonio Greco. I'm the medical director of the geriatric unit of the IRCCS Casa Sollievo della Sofferenza.
Hi, I am Daniele Sancarlo, Geriatrician and researcher from IRCCS Casa Sollievo della Sofferenza.
And I am Francesco Giuliani from IRCCS Casa Sollievo della Sofferenza, and I take care of the technological aspects linked to the participation of our institution to the Mario project. So I think that we can start with our presentation, and I'm going to share the screen with everybody who is connected to the YouTube channel. So let's start with the presentation. I will soon pass to Antonio. Here it is. So please, Antonio, you can start.
Okay. So I'm here again just to discuss with you about frailty and its measurement. So let me say just think about something about the population primates that says that people from European Union are becoming older. And a remarkable question is how these people can deal with this problem. So all the people that are older the same, can we understand that the age per se is not linked to some deterioration in health? So the problem is that sometimes it happens that what we call the usual stressor, the daily life stressors, have a different impact on people, depending on its ability to react and to maintain homeostasis. Derangement from this kind of homeostasis maintaining is called frailty. But let me give some example very similar to what frailty is. Here in this slide you can see the functional abilities plotted against dependent on independent of the activities of daily living. As you know, when you have a small disease like a minor illness like an urinary tract infection, you stay at the bed and you don't move, you don't go outside your home. This means that you lost your independencies in the activity of daily living. This is the same for people who is very fit, is independent, also of course for a person that is dependent. But the difference is that both the two people lost their functional performance, but the independent one goes back to the previous status when he recovers. The dependent subject instead do not recover completely and is assessed to a less degree of functional ability. This is frailty. But what is frailty in terms of phenotypes and of mechanism, physiopathological mechanism? As you see, the cycle of frailty has some similitude with some well-known conditions like heart failure or cachexia or wasting syndrome in uremia. The main goal in this kind of model is the loss of the muscle, that called sarcopenia, and the loss resting metabolic rate, and of course a voodoo max consumption and a strength and power reduction are the main characteristics of frailty syndrome. How do we assess really the need of older people? We know from the long time from this kind of meta-analysis performed by Stuck and co-workers that were published years ago on the Lancet that Comprehensive Geriatric Assessment is one of the procedures designed to improve the health of the elderly population, and it works determining an elderly person medical, psychosocial, functional, and environmental resources and problem, of course, to elaborate a strategy plan for rehabilitation. So everything that is going to deal with frailty of course, is strictly related to comprehensive geriatric assessment. But which kind of evaluation? Where are the main objectives for Frailty evaluation? Of course, we need to predict adverse outcomes, to predict the potential benefit of medical treatments in terms of risk-benefit ratio. It should be simple and to be strongly related to the physiopathological mechanism, NSA, to comprehensive geriatric assessment. So, because of the companion condition, like Thomas Gill, a geriatrician from the McGill University, says that diminished life expectancy, careful consideration of prognosis is particularly important for clinical decision making in older patients. And so, if we will be able to align clinical guidelines to this kind of indicator, it will be better to assume some clinical decision for this kind of patients. And of course, we need in this occasion, of validity indices that predict correctly mortality for older persons that are rigorously assessed for generalizability, accuracy, and potential bias. Here you can see in a recent meta-analysis in this recent work, all the index that have been validated in these 10 years. As you, there are a lot of them. All of them are mainly based on comprehensive geriatric assessment. And of course, here you can see the name of the index, the country of origin, the time that we need to perform this evaluation, and the number of items on domains that this kind of indices cover. Here you can see some of them that you know that are part of the MANIO project, like the MPI, the Multidimensional Prognostic Index, where you see this will be a good index to test frailty. But we are a lot of them, and maybe it seems to be much more complicated because geriatricians sometimes they don't work together to assess one single instrument, but there is a lot of them. So this could be also give some opportunity, but could be also a bias. Too many measures. Which one should be chosen? It's one of the biggest questions in the last years. So let me just go over the index. You see, one of them was from Kenneth Rockwood and Arnold McNeesty, that is a number of signs and symptoms that define frailty, and the presence of them say you are frail or not. But of course, there are also some different clinical models of frailty. One of them is the Fried model based on phenotype indication. 3 of them that were positive says you are frailty, or also the Canadian study on which was established the clinical frailty scale, identified the characteristic of the elderly people, ranging from the very fit to the severity frail. But time is a very important item to share this instrument across the real world setting. So a number of scales were developed in these years that should find the best compromise between to be precisely, sharp evaluation in terms of sensitivity and specificity and time needed to perform the measurement. So this is one of them is the Mondor-Frey scale, but you see we have some also simple instruments like the slow walking speed, the time out and go test, or the Prisma 7 question that is well used in the UK. Of course, they are very sensitive, but not so much specific. So if you go back to speak about the Mpi Prognostic Index, you can see that what can give an idea of what can predict 1 year mortality. You see that some of the Comprehensive Geriatric Assessment very clearly predict mortality. This is the same of the age, the ADL score, the EADL score, the short portable mental state questionnaire, and so on. So these are the domains that should be combined to elaborate a good index. This was what happened for the development of multi-prognostic index, and this is why MPI is scored. So it's the end of this is a continuous number that can be divided in 3 different groups: mild, moderate, severe, based on the score that you evaluate. And if you look at the development cohort, you see that the observed mortality versus the predicted mortality are very similar. This seems to say that the index is enough strong to predict mortality. And as you can see also, if you look at all the domains of the MPI, sex, ideal, ADL, short portable, each one of them can give us a score of prediction, but the index on his wall predicts much more better than each item per se. This seems to be that the addiction of the interaction between the domain is a better prognostic index than the single item we explore. And this is how the MPI works. This is how can divide the mortality into 3 groups. If you look in the survival function in the development cohort and also in the validation, you see the 3 curves that are well defined and separate between the 3 classes that say how mortality risk is distributed. And this happens in a lot of conditions. You see from the pneumonia, chronic renal disease, heart failure. And also, of course, in dementia. So these are to make you understand how this kind of instrument can be cross over different specialties outside the geriatric field. You see how it's important also for cardiologists to understand that alteration in functionality and in to understand how comorbidity and can predict the adverse outcome. You can see that what you're going to expect that this kind of instrument will be well shared among different specialties. This is what is now geriatric cardiology assessment that was used as a program for students for residencies in many US university, just to understand the patient with cardiac disease that is old now, as is in the center of multiple domain involvement. And this is just to give an idea what happens if you compare MPI as used as a Frailty index with concerning people affected by heart failure, and you compare this kind of index with the classical index like an AIH class and the effect of the risk scores. Here you can see the MPI seem predict mortality much more better than the other classical index used for young adults. And what is going over on dementia? Why we think about this kind of index for Mario that is well designed and properly used for people affected by dementia. You see that here, that is a very strong problem. We have, of course, frailty syndrome going over the stage of the disease. So you have a mild cognitive and functional alteration at the early stage, and then you have the maximum frailty after 8-10 years after the beginning of the disease. So what we should imagine, why we are going to understand and carry out this kind of webinar, because we understand that we go back and analyze the older patient's need, and the main with a special regard to central nervous system functionality, particularly with memory, because we are going to look very, very carefully to this kind of domain, because we think that in dementia dementia patients, memory is the cornerstone of his problem. So this is just to say that this is another feeling that we have as a doctors, but also economical people that coming from the world of the affairs, understand the importance of and the social usefulness of developing instruments for assessing the elderly people. And so the IBM, on which we are going to share some projects, understand the big value of helping people and developing the interaction between the technological science with the social one for the elderly population. So let me conclude just saying that frailty is not an inevitable consequence of aging. Frailty is best thought as syndrome with multiple possible components rather than a single condition. People with frailty who experience an acute illness will have worse outcomes than those who are not frail with similar comorbidities. And validating rating score to assess the degree of frailty a person has do exist, but they become cumbersome to use in the acute hospital environment. Comprehensive geriatric assessment associated with a tailored management plan is the gold standard intervention for diagnosis and treatment of frailty. And so let me thank you for your attention. And just to understand, we are going to move from the medical world to the technological one, imagining Julia Moore, an actress that well characterized a young person with early dementia, the stage of dementia, will cope with this disease with the technological aid of a smartphone.
After this extensive presentation about frailty and comprehensive geriatric assessment, I show you a brief overview of the possible application of ICT to compute GGA. The GGA is a simple concept, but it could be expressed in several forms with different complexity grades. So one of the most challenging aspects is to decide which domains include in a final model, considering different aspects: technological feasibility, computational capacity, intrusiveness, privacy, ethical aspect, clinical relevance, measurement, reproducibility, and so on. So, in order to simplify the frame, we have divided the variable to be recorded in basal, to be collected throughout the structured questionnaire, and current, throughout seriated and repeated measures. This could be the basis of the statistical model to compute the health status and consequently the action to be undertaken in the specific circumstances. The domains that we have chosen after an extensive review literature, considering over than 1,500 papers, is 8. In particular, the cognitive, the basal instrumental activities of daily living, nutrition, gait evaluation, vital signs, sleep, socialization, and compliance to the drug treatment. Regarding ICT in cognitive rehabilitation, the most promising technologies appear to be the implementation of social robot, virtual reality, and serious games. Of the last one, interestingly, some small studies seem to indicate a possible role of this application in the early diagnosis of cognitive impairment and cognitive performance benchmarking. But the majority of studies examined a small sample show that the introduction of ad hoc ICT tools are accepted, used, and could improve the quality of life, memory, brain performance, increasing the home performance. But clearly, we need further studies to validate the results and produce a formal recommendation to be implemented to a larger scale. The second domain that we have included is insomnia, because seem to be related to disability, risk of injury, impaired quality of life, cognitive impairment, depression, metabolic syndrome, and risk of cardiovascular disease. And in particular, we have categorized our results in 3 main domains: the internet delivery, cognitive behavioral therapy, virtual coaches, and sleep technologies. The technology application have the potential to improve insomnia, reducing caregiver burden and its negative outcomes, as you show in this table, improving quality of life for families and reducing healthcare costs. Now, we have also reviewed the possible application of ICT to ADL, IADL, that stand for Activity of Daily Living and Instrumental Activity of Daily Living. This is the cornerstone for geriatrics, because this domain is really wide and many progress as was made in the gesture recognition, but it is far to be perfect, especially in the real environment. We have divided also in this category 5 categories to indicate the possible application. So for technologies used by patient, caregivers, monitoring system, ambientes adhesive living with ICT, and tracking and Wi-Fi. In particular, we have found 21 studies that adequately address our topic. The greatest number of ICT were designed to assist with ambulation, housekeeping, and social communication, whereas a smaller number of ICT were found to support dressing and toileting. Long-term experimentation are essential to assess the real efficacy of the ICT, the acceptability, and corrected use by the patient and caregivers. Moreover, to explore the burden level or caregiver that use ICT in patient management could be an important indicator of ICT effectiveness. The question of acceptability and usability was another important issue to explore. Patients and their caregivers are sometimes skeptical about accepting the installation and use of ICT in their life environment. The estimation of usability and susceptibility aspect of ICT so is fundamental to guarantee the suitability of this solution in really daily context. Regarding the monitoring of vital signs, is a really complex context because many wearable sensors exist on the market capable to record data about blood pressure using also cuffless methodology using the pulse wave transit time or pulse rate or EKG or respiration rate, respiration effectiveness, body temperature, blood glucose, using also non-invasive sensor, impedance spectroscopy, and so on. But this field appears in very fast growth because regard not all medical aspects, but also fitness and well-being, and so is really more commercial. One of the main issues was to select the more appropriate technologies for the patients, avoiding more than 2 wearable tools and searching to find something that could be reliable, accepted, cheap, and with less enthusiasm as possible. Well, the ICT to improve compliance to track treatment appear really promising because it's really simple to do, but in the same manner, the system could be accepted from the user, and the system could be capable to understand the user in order to be accepted on long term, because therapy must be taken for long-term period, not for short time. And this is the next challenge in this field that appear really interesting. Regarding gait evaluation, a great number of sensor and robotic technology exists to be used for gait and mobility evaluation. But the vast majority of technology are based on images, accelerometer, and gyroscope. Now, exploiting the potential for technology to meet care for elderly patient needs depends on the number of factors, including raising awareness of available technologies and their utility, promoting accessibility, affordability, and overcoming challenges to acceptance to use. The last one is the conversational agents. There are many e-commerce available, and regard robot and communication interface, virtual conversational agents that appear to be interestingly in terms of results. But also in this case, we need more studies to be validated. So, to conclude and summarize, we show you a table of the technologies in order to be included in our project, with a summarized clinical value and the suitability to be implemented in a short time. Well, many technology exists and will be available in next year, suitable to be implemented in a platform capable to perform HGA. But they need to be validated and properly integrated in respect to the subject habits, permitting to develop new health predictive model.
Okay, Daniele, thank you for having shown us technological possibilities that we have today, and I will briefly give you a glimpse on what can be done with the things that we have now in Mario to build an index that can be important to support the CGA process on the field. You have seen, in the words of Antonio, what MPI is. So just let me summarize. You would like to find some numerical indicator that as soon as possible can give you a rapid indication of what adverse outcome you are going to expect. So let's start with the classical definition that you can find in many articles in literature, and also in this one that I've shown in this slide, that is particularly interesting as it is applied to people with dementia. That is also they are the subjects of Mario. So in a traditional way, to compute the MPIs, this let's imagine it just like a number going from 0 to 1. 1 is a seriously ill patient for which there is a poor prognosis. So it is very likely for him to have an adverse outcomes and so on. So you can find him here the formula for the simple formulation of MPI. So you have to take these TI values, you can give them a weight and just make a sort of average of the results in the different domains. ADL, that I just remember, are the activities of daily living and so on. So the setting is made in this way. You have a sort of tests. You deliver these tests to the patient or to the caregiver. You assign some values to these tests and then compute a sort of mean of this. What does it happen when you have a robot to make these kind of things? Let me say that the ideal case is the one in which Mario is capable of making the computation of MPI by itself without a human intervention. In the sense that in the future, I hope that there will be a robot with this kind of features, a robot that can be capable of observing the patient and extracting from what it observes all the values needed to make the computational MPI. We are far from this kind of scenario. Now we have a Mario CGA app in which essentially Mario asks to the patient the single questions that make up the MPI. Then the patient answers, Mario interprets the answer, and then can record the answer in its database to compute the MPI. In this case, with a robot, we have a first source of error that we can call a comprehension error, in the sense that Mario is not able in every case to understand perfectly which is the answer of the patient. So in case the answer is not above the threshold, the statistical threshold that the speech-to-text engine has to associate this reply from the patient, this answer, to an exact value, you can have no answer to some questions, so no values for some questions that Mario made. In this case, so there is a first source of error, so the not perfect ability of Mario to understand what the patient says in reply to the question. And then you have another important source of error that is a sort of misclassification error, and this is the typical case in which Mario understands things, let's say things that it understands what the patient has said, but it is not the right answer. In this case, we can say that Mario is capable of semantic error, so it misclassifies the answer. And to avoid this kind of error, we are setting up a trial in which the answers are collected by healthcare professionals who blindly, in parallel, acquires the questions, not knowing what Mario has interpreted as the answer given by the patient. So essentially, we are acting in a way that that considers the answers as registered by the healthcare professional as the perfect answer, a sort of gold standard to which Mario has to tend if we can consider Mario as acceptable. In this case, if we have systematic errors, as you can understand, you have to explore the possible causes. So maybe the questions need some kind of reformulations. They are not maybe comprehensible understandable by the patients, or it can be also a guide in defining a better user interface. And then you can consider a sort of final model in which you put into the model the first thing, that is this kind of errors due to the fact that there is a robot making questions and interpreting answers. And we have also the possibility to gain some insights from the sensors that are connected to Mario and from other Mario apps. In the first step, we are trying to evaluate, thanks to the Fitbit device, some parameters linked to health, to the physical health of the patient. So, as you can see, heart rate, respiratory rate, or blood pressure. In this case, they add up to the model as variables that anyway need to take values that are of significance according to the history of the patient, and also according to clinical considerations. So it's quite a really not automatic model, but you have to start in this way, given what we have now. And there is also very important that in Mario we will host applications to make a sort of cognitive rehabilitation, or in a sense to cognitively stimulate the patients. So also the results from the games that we have can be also parameters to enter into this model. Okay, and then the final aim is to define a new version of MPI based on the robot. And in this case, you can start from many statistical tools to assess the value of the robot in this calculation of MPI. We tried to start on the basis of what we had. We had a traditional MPI computation, and we tried to enrich it. It is also really clear that we are not in the condition, given the time span of the project, to have a final model on which Mario could be based to the computational MPI, because you have a longer time to measure the effects of the exposition to the robot. So you need 2 or 3 or 4 years. In fact, if you consider as an endpoint, as an adverse outcome, the death of the patient, you virtually need many years to do. But this is the start of something that anyway, it needs to be started, and we are very sure that the model is far from perfect, and we are very open to any contribution that can come to enrich this model and make it more performant. Thank you very much for your kind attention. We are ready for the question and answer section of this webinar. So let me put off the screen sharing, and maybe, yes, you are able to look at us.
Okay. Thank you for the presentation.
You're welcome.
We have a few questions. Let's start with the last presentation.
Yeah.
Go to the second and then the first again.
Yeah.
And we have some kind of broad question about the ethical standpoints and what are the most challenges in the ethical background for automating CGAs.
Yeah. Yes. It is very important. I thank you for the questions, for this question, because it's very important that you have to consider that you are sort of transferring a human activity to a robot-based activity. So there are many ethical considerations that you have to take care of. The first one is that we do not intend Mario as a substitute of the healthcare professional traditionally delivering CGA. You have to understand that the CGA is a complex process, and the things that Mario can do is just the first part of the CGA. That is just acquiring some information on the state of the patient. Then the most important part is planning a therapeutic scheme that can work for this patient. So we try to do this kind of thing. Let's make Mario the CGA that is the most repetitive part of this process, and let the healthcare professionals have more time to dedicate to the most important part of CGA, that is, given the results of the picture that you have of the health of the the patient. Let's think about the therapeutic plan and so on. And so I think that this is the most important issue. I don't know if I have understood the question, but for me this is very important. So Mario is not a substitute for the human operator, healthcare professional, and it can ease the regaining from the healthcare professionals of a role they now do not have because they have not sufficient time. They spend all time making the picture of the patient. If Mario lessens this time, they will have the time to do more with the patient.
Thank you very much. I think that answers the question. And we have another question. Where is the main perception of value for these technologies in the geriatrics community, and where is the most pain for this community?
So let me say that it was very surprising also for me, because we were very upset about the acceptability of Mario among all the elderly people. But very surprising to understand that people are also, the people are very familiar with new technology, are curious, and they understand that Mario could be a good partner to play games and to enhance their capabilities. So maybe just because this is new, like all the new things, is to be very good, very suitable for the purpose we arrange. But let me say also that the main goal of Mario should be to preserve the functional ability of the people outside and inside the hospital while they are affected from some other problem. In the hospital setting more, when we test Mario, we imagine that dementia is a comorbidity of an acute problem, like for instance pneumonia or urinary tract infection. This means that in times you recover from the pneumonia and you are away from your family, you're away from television, you're away from social services, you lose a lot of stimuli that can help your brain to be active. And so we want to prevent this with Mario. Of course, just to try to answer the other question, we would like to gain as many information from vital parameters from Mario or something similar. But of course, we can also understand that we must understand that Mario is a startup, and it's better to gain good information than many unusual information.
Yeah.
So we are working about that, and we try to understand that Mario could be a good platform to share functional and also fundamental vital signs to people that are responsible for healthcare. Healthcare professionals also in hospital are not every time with the patients. So Mario can watch if the patient immediately goes to the floor because he's on a cardiac arrest before the nurses that are maybe 10 meters, 20 meters, but they can see the patient because there are walls, of course, in the rooms. So if we imagine the future scenario, we can understand how Mario or something similar can cooperate with their care professional. As Francesco and Daniele said before, we are trying to cooperate and to better works, not to substitute people, especially for healthcare, because this is not our intention, I think. And of course, this is applied much more on people that are at home, away from the acute hospital. So it's very important for us to test Mario in this condition.
Yes, thank you. In connection to that question, in your opinion, which other functionalities would you like to see in Mario in mid to medium term?
Okay, so the medium term could be really interesting to implement some functionality related to the sensing emotional. Emotional sensing could be a really interesting application because it could be a feedback for every action that we've taken with the robot and from the robot to a person. Especially elderly are a really complex person with his rhythm, his habits, his use. So it's really important to understand deeply and in a particular way which is the emotional impact of our action on this person, also to tailor our intervention to this particular subject. Okay.
Yes, we totally agree.
Okay, you talked about sensors and more information about that Mario could gain. What kind of sensors do you see are needed in addition to support Mario better?
Yeah. And now we are planning to test the embedded sensor to monitor sleep, in addition to the sensor integrated to the robot, and also the Fitbit to monitor heart rate, frequency rate, and other aspects related to the mobility. In this case, the integration of this data to the other data related to the robot and by the Kinect could be really important to compute our health index, especially because now in the future we have structured questionnaire that give us a basal status, and then we have continuous data that could be really relevant to us to perform a health continuous analysis, so we can determine in more precise and accurate way the health status of a specific subject in a specific moment, and so we can tailor a specific intervention for this kind of patient.
Yes, thank you. And touching from that, where do you think that what is the main functional strength of Mario? Is it to support patients, or is it to support the staff that handles the patients?
I should say both of them, because it's better for the patient because it preserves functional ability, but also for the staff because it can save time just computing CGA. This means that we don't lose the time. We can use the time we serve to do it many times and to give much more time to stay and talk with the patients. Give them our attention much more. So some process can be automated. Maybe we have more time to give the patients to share.
Yeah, and if I can also add my opinion, I think that the basic idea of Mario of having apps that can be installed can make the same object useful when it is in a hospital and when it is at home. The app can be really different. Maybe in the hospital, the app will integrate with an environment of clinical health records, of Internet of Things, such like kind of things, to ease the work of healthcare professionals. While at home, you can have different apps that can make equally useful this technological object in a different context. So I think that this is a killer advantage of Mario, the possibility to customize the use of the robot basing on the context in which you use it. And the other thing that told Daniele is very important. You have to customize the interventions to tailor it exactly for the state of the patient. Is very important. From an acceptability and in general from if you want it to be useful, essentially. Yeah, it's not a mass product in a sense. You have to tailor really well it for the setting and the people.
Yes, well, thank you. We have one more question. And yes, in one of your last slides, you listed many different technologies, not limited to robotics. Which one is the most exciting to you, and which one has the highest short-term feasibility for implementation?
The most exciting to perform is the use of virtual coaches that could be really relevant for the life of the patients, because for virtual coaches is extremely wide terms that include many applications, but the capability of the system to understand the person, to to interface with them and conversion with them is something that was really interesting, which at the basis of the intelligence artificial. The most feasibility is the integration of sensor for frequency rate, sleep monitoring, and to connect to detect emotion at a low level, or to understand which action will be performed. Also, because we have also integrated in Mario an RFID sensor, so we have the capability to integrate the data from the Kinect to the data of with RFID and to the other sensor, in order to improve the capability to understand which action are undertaken from a person. But this is a research on this, so it's not real, but I think that could be feasible before the end of the project. Just another one could be also the emotional detection through the analysis of the speech. This could be another aspect that could be really interesting. So we can analyze the emotion of the person on the basis of the positive or negative of a single term that we have expressed. So I think that
the terms
would be interesting.
Okay, thank you very much for your presentations.
You're welcome.
For answering all the questions. We currently have no more questions, so I think we can thank you again.
Okay.
And let's hope that we will wait for the next webinar.
Thank you so much. Thank you so much.
Bye.